before this class. So here we go. Trigonometry right triangles. This is where you get the phrase Sohcahtoa. Again, you don't have to know Sohcahtoa to solve right triangles. I never used it once when I was in high school. But here's what it refers to. That's my angle. Every time you draw the angle, it consists of two parts. The hypotenuse, which is the longest side, and then the other side of the angle that is used, or the other side that's used to make that angle is called the adjacent side. Adjacent means next to, so it's part of the angle. The side across from it is called the opposite side. We will not use these three really for solving right triangles. We just generally don't talk about them. So sine is the ratio of opposite divided by hypotenuse. Now again, I told you that I thought of this as y, I thought of this as x, I thought of this as r. And so, that's how I always just looked at the triangle. And so I just continue to think of sine as y over r. But whatever, free country, do what you want. Cosine is going to be adjacent divided by hypotenuse. And tangent is opposite over adjacent. So a lot of times people's question is, I forget how to find the adjacent side. The adjacent side is the side that helps make up the angle. Okay? All right, so example 1, find the exact value of 6. We're just going to go 3, because I can change whatever I want. We're going to do sine of theta, cosine of theta, and tangent of theta. So right now I have a triangle with theta. What is sine of theta? What is that fraction, that ratio? 5 over 13. Can I determine cosine? What do I have to find first? The length of the adjacent side. How would you find the length of the adjacent side? Pythagorean theorem. 5 squared plus b squared is equal to 13 squared. 25 plus b squared is 169, or b squared is 144. Therefore, b is 12. So cosine is 12 over 13. So you notice it works out very nice that it is an integer, 12. Maybe you remember some of your Pythagorean triples. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Any of the multiples work as well, such as 6, 8, 10. We can generate new Pythagorean triples in case you get bored any day. But there you go. So tangent would be 5 12ths. You see if you can do the next one on your own. Find sine, cosine, and tangent. Notice that theta has kind of moved location. The triangle's, tipped a little bit. Okay, you should come up with a hypotenuse of 2 roots of 5. So sine simplifies to 2 roots of 5 over 5. Cosine is the root of 5 over 5, and tangent is dos, which is Spanish for 2. Is there any questions how I came up with those? Questions going once. Oh, I was going to say, what happened to Lolly? I thought she was gone. Okay. All right. Questions going twice. And 3 times gone. Flip it over. Solve for the missing side of a triangle. So using trigonometry and our ratios, we can now apply this in order to find missing sides. It used to be in triangles that you had to have 2 sides to find the third side, use the Pythagorean theorem. But now at trig, if you're given an angle and a side, you can find one of the missing sides. So in this situation, I draw the angle 42 degrees, and that tells me that this is the hypotenuse, this is the adjacent, and this is the opposite. So will I use sine, cosine, or tangent to find x? I will use sine. Why? Because I'm looking for the hypotenuse and I have the opposite. So I need the one that matches up with those two. So it's sine of 42 degrees is equal to the opposite 9 divided by x. Sometimes people get used to always putting x in the numerator. X can end up in the denominator. And in order to try to refrain from making mistakes, I encourage you to write it over 1 and to cross multiply. So therefore, 9 is equal to x sine of 42. I will solve for x by dividing both sides by the sine of 42, and I get 9 over the sine of 42 is equal to x. I take out my fancy-dancy calculator, and I listen to B. Rodden, who says 9 divided by the sine of 42 is 13.45. Notice I'm working in degrees or radians. That's up to you to figure that out. So on the test, when you start solving for right triangles, make sure you're working in degrees. Why? Because it says degrees. If you ever press sine, cosine, or tangent, you have to make sure that you're in the right mode. So I press mode, I figure that out. So he got 13.45, and does it make sense that the hypotenuse should be longer than the opposite side? It does. We look at the next one. Again, I draw my angle. You don't have to do that. I'm doing it because I need to teach it. I want you to understand it. So this is the hypotenuse. This is the adjacent. And this is the opposite. Sine, cosine, or tangent. Cosine of 63 degrees is equal to the adjacent x divided by 14. Cross multiply, get x is 14 cosine of 63. Oh, what am I doing? And I get 6.36. Does that make sense? That's shorter than the hypotenuse. Now, I'm going to take a chance and just show you for 1 minute. Hey, where'd you go? Uh-oh. Yeah, so I'm going to have to fix that. So anyway, here's... Calculator is able to figure that out. Cosine 63. Holy cow. If I press that cosine, turn on. Come on. If I go cosine of 63, notice what I get. I don't get 0.5, I get 0.45. How does your calculator even know that? It's smart. You guys, we're the ones that invented the stinking calculator. We got to be smarter than it. So how is your calculator so smart? Okay, all right, you say because it's genius. Try one more, okay? This is my last shot at trying to impress you, okay? Understand that we have to tell the calculator what to do. The sine of x, one thing that we learn in calculus and calculus 2 is that any function can be written as a polynomial. So sine is actually the same thing as x minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial plus x to the ninth over 9 factorial, going on forever. Okay? So here's the cool thing, all right? So your calculator has this formula punched into it. So when you say sine of 63 degrees, it converts it to radians and plugs that in for x. It comes up with a number. We had to tell it to do that. So what did the people do before they had calculators? That's ridiculous, folks. You know what they did? They had idiot savants do it. People who have a low IQ, but the intelligence is really fixated towards one part of the brain, and they're really good at a single task. And so idiot savants are really good at like one thing. And so if you give them like 28.345 times 1.634, they can spit out the answer just like that. And so what they would do is they literally employ them to sit down every day, and they give them a set of numbers, and they'd say, okay, plug 63 in there, then plug in 63.01, then plug in 63.02. They do it for sine, cosine, tangent. They would do it for natural log. They do it for log. They would do it for the square root of 5, the square root of 6. They would do it for all these different things, and they'd come up with these values. And that's how we first came up with those tables. So pretty cool if you ask me. You try the last one on your own. Go. You guys already do it? Did you already get it? Some people already got it. So I'll just go over it. So we got a 27-degree angle. Sine, cosine, or tangent? Tangent of 27 is equal to x over 9.4. Cross multiply 9.4 times the tangent of 27 is equal to x. And by the way, that's how you probably see the answer on the ACT. They'll probably leave it like that. They won't write as a decimal. But as a decimal, what is it? 4.79. Piece of cake upside down. Everybody good? Okay, 2 more examples. We're just going to do this one. We're not going to do this one. Then we're going to do this one, not the last one, and then we're going to go to your assignment. Sine theta is equal to 3 over 7. It says sketch a triangle that has the acute angle theta and find the 5 other trigonometric ratios. So I want to know sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta. So I've got theta. What should I mark the sides if sine of theta is 3 over 7? Where do I put the 7? Yes, Terry. We like to hear your voice. Speak louder. So 3 and 7, we got it. Could I have done, instead of 3 and 7, could I have done 6 and 14? Yeah, there's an infinite number of triangles that would satisfy that ratio. We're choosing 3 and 7 just because it's easiest. How do I find the other side? Pythagorean theorem. A squared plus 9 is equal to 49. A squared is 40. 2 roots of 10. So what sign? 3 over 7. Cosecant 7 over 3. Cosine 2 roots of 10 over 7. Secant, I got to flip it. So 7 over 2 roots of 10 multiplied top and bottom by the root of 10. And we get 7 roots of 10 over 20. Tangent. Well, cotangent would be 2 roots of 10 over 3. Tangent is 3 over 2 roots of 10. Or 3 roots of 10 over 20. Not too bad, huh? So nice to be able to take this and understand that it comes from a triangle which you can apply certain properties. So I use this stuff all the time. I'm a woodworker. I work on my house, do all sorts of stuff. I haven't done the kite situation before, but I have used trigonometry to determine if a tree is going to fall down and hit my house. And it turns out one tree is going to be about 3 feet short from hitting my house. Turns out the other one will hit my house. So I have to remove that one this spring. So, do I use this stuff for real life? Yes. So is Jill. Jill is flying a kite. Way to go, Jill. You got a small neck. All right. Jill's got this string let out. She's got a kite at the end. She's having fun, flying her kite. She's got 500 feet of string that's let out. It's lightning outside. Her hair is standing straight up. And she's able to kind of eyeball and say, well, it looks like about a 36-degree angle of inclination. Why is that funny? You don't think Jill's smart enough to do that? Terry? The way I said it, you blame me. Sure. All right, whatever. Okay, so she's wondering what the height is. How far does it stick off the ground? Help me out. Come on, you're the best of the best. Sine of 36 is h over 500. Cross multiply 500 times sine of 36 is equal to h. Somebody give me a number. Starts with a 2. 293.89, and that's feet. Now, Jill knows that it's 293.89 feet above the ground, which is important to her. It will not interfere with airplanes. Lauren, you don't have to laugh at my jokes, but you can pretend to be entertained, okay? All right, so why don't I give you an assignment, and let's do the first 2 problems together so you know what the heck you're doing. All right, here we go. So solve the following triangles at given conditions. Let C equal 9 degrees for all triangles. You guys are going to be solving triangles today. So I gave you kind of an overview of Sohcahtoa. We're going to refine our skills and what we need to know for the test to this point right here. Every triangle will have a 90-degree angle that we refer to as C. Check? All right. You can choose which one you want to be angle A or angle B. It says B is 32. That's going to be the smaller one, so I'm going to label that B, 32 degrees. The big letters are all angles. The small letters are all sides. The small letters are across from the big letters. So angle C, side C. Angle B, side B. Angle A, side A. Remember that from geometry? All right. I need 6 parts to my triangle. I've got 3. You tell me how to find one easy. These all got to add up to 180. 180 minus 90 is 90. Minus 32 is 58. That was easy. All right, I'm going to choose to work with angle B. I'm going to choose to work with angle B. Do you want to find side A or side B? It's up to you. You want to find A. Okay, Jayaki wants to find side A, so we're going to do that. He wants to find side A, and he's given 8. So if he's using the angle 32, is he going to use sine, cosine, or tangent? Cosine of 32 degrees is equal to A over 8. Or 8 cosine of 32 is equal to A. What do you get? 6. 6.78. Pythagoras, yes. He tells us that a squared plus b squared is c squared. So 6.78 squared plus b squared is equal to 8 squared. Wish I could have met Pythagoras. You sure could. You could also say sine of 32 is b over 8. What? 100th. That's fine. Okay, I want you to check this out. This is a way to check to see if your answer is reasonable. Reasonable. Biggest angle, biggest side. Smallest angle, smallest side. The bigger angle should correspond with bigger sides and the other way around. This way to check to see if your answer is reasonable. All the ones on the left-hand side will be like that, where you start out by finding an angle. These ones are different. We got angle C, which is a 90-degree angle. So that is 5, B is 12. So we got B and we got A. What's different about this problem? Hey, you're not given an angle. So what do we do? It's a Pythagorean triple. It's not 45, 45, 90. It's not 30, 60, 90. So we can find the hypotenuse. It's 13. Because 5 squared plus 12 squared is 13 squared. We already did that before, right? I don't have an angle. Shoot. Okay, excellent. So, Jackie, do you want to find A or B? It's up to you. You want to find B. Would you like to use sine, cosine, or tangent? Entirely up to you. Cosine. So we're going to take the cosine of angle B. Okay? So we just got angle B right here. What is the ratio of cosine of B equal to? 5/13. Now, you can see what's different about this is I don't know the angle. Just like I showed you that incredible formula that your calculator has to calculate exact values, it has another formula that will find the angle. Instead of pressing cosine, we press second cosine, or cosine inverse. This doesn't mean 1 over cosine. It's not secant. This means undo the cosine operation. Instead of giving me a side, give me an angle. And we type in that 5 divided by 13. And when we do that, we get 67.38. Subtract from 90, and we get 22.62 degrees. So all of the triangles on the right-hand side, you have to find an angle. The ones on the left-hand side, you're going to be finding sides right away. Did you guys do that in geometry? Some people remember, some people don't. I found that out from the classes. I helped somebody with some geometry last year, and they were working on this kind of stuff. So, but doesn't mean you remember it all. I get it. The rest of the time is yours. Go to work. Yes.